In 17 countries around the world, researchers wired volunteers to sensors and played them news clips. Positive stories barely moved the needle. But the moment a negative headline appeared, heart rates shifted, skin conductance spiked, and pupils dilated. Every single time, in every single country. Something inside the human brain treats bad news like a fire alarm, and no one taught it to do that. Picture a quiet polygonal living room at dawn. A figure sits on a low poly couch, coffee in hand, scrolling through a glowing tablet. Dozens of headlines float above the screen like translucent tiles. Most of them are blue and calm, but one tile is deep red, and the figure's eyes lock onto it instantly, as if the red tile has its own gravitational pull. This is not a choice. This is not pessimism. This is architecture. In 2001, a team of researchers named Rosen and Roisman published a paper that would reshape how psychology understands attention. They found that negative events, negative objects, and negative traits all carry greater psychological weight than their positive equivalents. Not slightly greater, fundamentally greater. And they identified 4 distinct dimensions of this asymmetry. The first dimension is negative potency. A single bad experience hits harder than a single good one of the same magnitude. Imagine 2 geometric scales floating in a dark void, perfectly balanced. Place a green cube on one side, a compliment, a kind word, a sunny afternoon. Now place an identical red cube on the other, an insult, a rejection, a gray morning of bad news. The red cube sinks lower, every time. The second dimension is the steeper negative gradient. As events become more extreme, negative ones gain psychological intensity faster than positive ones do. Walk down a long, crystalline corridor where the walls shift color from pale yellow to deep gold on the left, increasing joy. On the right, the walls shift from light gray to black, increasing dread. The dark side of the corridor grows overwhelming long before the golden side reaches bliss. The third is negative dominance. When good and bad are mixed together, the bad disproportionately shapes the outcome. A mosaic wall built from hundreds of bright tiles, turquoise, amber, white, with just a handful of dark tiles scattered through it. Step back and look at the whole wall. Your eyes find the dark tiles first. They define the pattern your brain remembers. The fourth dimension is negative differentiation. Humans have richer, more detailed vocabularies and categories for negative experiences than for positive ones. We have more words for pain than for pleasure, more names for fear than for calm. If you have ever wondered why one cruel comment can erase a dozen compliments, this is the machinery behind it. You are not broken. You are running ancient software. A vast geometric savanna stretches to the horizon. Low poly acacia trees dot the golden landscape, and a small group of angular figures moves through the tall polygonal grass. One figure freezes. In the distance, a shape moves. Maybe a predator, maybe just wind in the brush. The figure who froze survives to pass on genes. The one who shrugged and kept walking sometimes did not. This is the evolutionary logic that Baumeister, Brodslavsky, Finkenauer, and Vos laid out in their landmark review paper, also published in 2001, simply titled, "Bad is Stronger Than Good." They examined hundreds of studies across domains, relationships, learning, memory, emotion, health, and found the same pattern everywhere. Bad events outweigh good ones. Bad emotions linger longer. Bad feedback changes behavior more powerfully than praise. And, they argued, the reason is survival math. If an ancestor underestimated the threat, the cost was death. If an ancestor overestimated the threat, the cost was merely wasted energy. Over hundreds of thousands of years, the brain learned that false alarms are cheap, but missed dangers are fatal. So the alarm system got louder, and it never got a volume knob. Zoom into a translucent polygonal brain floating in dark space. Neural pathways light up like fiber optic cables. Watch as a positive signal, a soft green pulse, travels through the network. It activates a few nodes, dims quickly. Now watch a negative signal, a sharp red pulse, travel the same network. It branches wider, activates more nodes, and the glow persists long after the signal has passed. This is what the research on feedback processing shows. Negative feedback is processed more thoroughly than positive feedback. It is retained longer in memory, and it produces larger changes in subsequent behavior. A teacher who gives a student 9 compliments and 1 criticism will find that the criticism is the sentence the student remembers a month later. A crystalline classroom takes shape. Rows of geometric desks, a polygonal teacher at the front, small angular students listening. Above each student's head floats a cluster of translucent words, feedback they have received. The bright words slowly fade like evaporating mist. The dark words stay solid, hovering, sharp-edged. Now step into a different scene entirely. A 1946 laboratory, reconstructed in clean geometric shapes. Solomon Asch sits behind a minimal polygonal desk, handing out cards to participants. Each card contains a list of personality traits describing a stranger. The lists are almost identical: intelligent, skillful, industrious, determined, practical, cautious. But in some lists, one word is different. One single word. When that word is warm, participants form a favorable impression. When that word is cold, the impression darkens dramatically. But here's the finding that matters for our story. When Asch mixed clearly positive traits with just one negative trait, the negative trait dominated the overall impression far more than any single positive trait could rescue it. One dark polygon placed among a constellation of bright ones pulls the entire constellation toward shadow. This is why job interviews feel so terrifying. Not because anything is likely to go wrong, but because the brain knows, at a level deeper than logic, that one stumble will be weighed more heavily than 5 smooth answers. A geometric office building rises from the ground, glass and angles, and inside it, a small figure sits across from 3 interviewers at a long triangular table. Above the figure's head, a thought cloud swirls. It is not replaying the strong answers. It is looping the one moment of hesitation, magnifying it, saturating it with red. Rosen and Roisman gave this phenomenon a memorable name. They called it the moral contagion principle. One negative element contaminates its surroundings, but one positive element does not purify a negative context. One bad apple spoils the barrel, but you cannot throw a good apple into a barrel of rotten ones and expect it to fix anything. Picture a long banquet table covered in bright geometric fruit, green, orange, gold. At the far end, a single dark piece of fruit pulses with a faint glow. Slowly, the darkness spreads along the table like ink in water, touching each bright piece and dulling its color. Now reverse the experiment. A table full of dark fruit. One bright piece placed in the center. Nothing changes. The brightness stays contained to that single piece, unable to push back the surrounding dark. This asymmetry is not limited to impressions of other people. It operates in how we evaluate our own lives. A figure stands in a geometric field at dusk, holding a glowing ledger. One side lists the day's good moments in soft blue light. The other lists the bad moments in red. There are more entries on the blue side, but the red entries burn brighter. and when the figure closes the ledger and walks away, it is the red light that leaks through the cover and follows them home. That 2019 study from Soroka, Fournier, and Neer in the Proceedings of the National Academy of Sciences confirmed that this pattern is not a quirk of Western culture. Across all 17 countries tested, spanning multiple continents, languages, and political systems, participants consistently showed greater physiological arousal in response to negative news broadcasts compared to positive or neutral ones. The body reacts before the mind even forms an opinion. If you recognize this pattern in yourself, if you are the person who lies awake replaying the one thing that went wrong today instead of the 10 things that went right, you are not malfunctioning. Your brain is doing exactly what it evolved to do. The problem is that the environment has changed and the software has not been updated. A wide, geometric cityscape at night, glowing with soft neon polygons. Thousands of tiny screens embedded in buildings, sidewalks, and floating billboards all pulse with information. The ancient savanna is gone. The predators are gone. But the alarm system built for that world is still running at full power. And now it is pointed at emails, social media notifications, and quarterly performance reviews. Clinical psychologists have long recognized an extreme expression of this bias. They call it catastrophizing, the cognitive pattern of automatically jumping to the worst possible outcome. It is a core concept in cognitive behavioral therapy and rational emotive behavior therapy, frameworks developed by Aaron Beck and Albert Ellis, respectively. Catastrophizing is not simply worrying. It is the mind treating every uncertainty as a confirmed disaster. A figure stands at the edge of a geometric cliff, looking down. Below, the landscape fractures into multiple branching paths, dozens of possible futures fanning out like a low-poly river delta. Most paths are lit in neutral tones. A few are bright, but the figure's gaze is locked on the 2 or 3 paths that descend into darkness, and in their mind, those paths expand and multiply until darkness is all they can see. This is negativity bias pushed to its limit, and it is strongly associated with generalized anxiety, a state where the alarm system is not just loud but continuous, scanning for threats that may never arrive. A geometric control room deep inside a translucent brain. Banks of angular monitors line the walls, each showing a different feed of the outside world. In a calm brain, most monitors display neutral or positive signals, with a few flagged in red. In a catastrophizing brain, every monitor has been retuned. The software has cranked up the contrast so that even pale gray signals register as threats. The operators inside, small angular figures at their stations, are exhausted but cannot stop scanning. So here is what we now know. The brain does not weigh good and bad equally. It never has. Negative information is detected faster, processed deeper, remembered longer, and given more influence over decisions. This is not a flaw in a few unlucky individuals. This is a universal feature of human cognition, confirmed across cultures, across domains, and across decades of research. But knowing this, truly understanding the mechanism, changes the equation. A figure walks back into the polygonal living room from the opening scene. The same couch, the same glowing tablet, the same floating headlines. The red tile is still there, still pulling at attention. But now the figure pauses. They notice the pull. They see the asymmetry for what it is. Not a message about the world, but a feature of the lens they are looking through. Understanding negativity bias does not make it disappear. The red cube will always weigh more than the green one. The dark tile will always catch your eye first. The cruel word will always echo longer than the kind one. But there is a vast difference between being pulled by a current you cannot see and being pulled by a current you have mapped. A wide aerial view of a geometric ocean at night. Beneath the surface, deep currents glow in red, powerful, ancient, constant. On the surface, a small angular boat moves steadily. It is not fighting the current. It is not pretending the current does not exist. It is simply adjusting its course, because the navigator finally has a chart that shows where the invisible pull runs strongest. The next time you catch yourself spiraling, replaying the one mistake, fixating on the one criticism, bracing for a disaster that statistics say is unlikely, pause for a moment. That is not reality giving you a signal. That is your ancient alarm system earning its keep. It kept your ancestors alive on a dangerous savanna. It just does not know that the savanna is gone. You are not broken for feeling this way. You are human. And the first step toward navigating the bias is simply knowing it is there, built into the walls, wired into the circuits, older than language itself. The alarm will keep ringing, but now at least, you know what it is, and you get to decide what to do next.